Alright, here's what we did on review day geometry. I'm going to start off by going through the quiz, and I'll go through both forms of the quiz, and they're staggered enough, I think, when I do, where I have some of the answer in simplest, in radical, exact form, and decimals on the same type of question. I think that's going to give you a good indication of different types of problems you have to do. I also got some other problems thrown in here that were not on the quiz that might be good. So, and then when I save this file, it will have everything we did on the review day and all this stuff, and you can have that to look at your convenience. Okay, this is a 120-degree angle. The length of this segment, oh, you know what? Yeah, the length of this segment is 10. I'm trying to think, is that the way we did it in class? I don't know. Okay, if the length of that segment is 10, well, I don't actually want to talk about that length of that segment being 10. I want to talk about, you know what, I think on the other one, I think in the other form, let me just check this quickly. On the other form, it has the length of that segment. I was thinking we were talking about arc length. I guess that was a do now. I've done so many different ways of these same problems. I'm starting to get confused. All right, if the distance from A to C, not the length of the arc, but the distance from A to C is actually 10. This thing, yeah, I think it was a do now question where I give you the length of an arc and a degree of the arc. Here I'm giving you the length of the segment and the degree of the arc. Totally different. If that's 120, these are 60. You know, you start seeing simplified radical form or exact, you start thinking, okay, everything's going to be able to be doable in square roots and pies and stuff, so we're not going to do anything crazy like 52 degrees. It's going to be something nice. 60 is nice because this is a 30, 60, 90 triangle. Whatever this radius is, this thing is half of the radius, and this thing times square root of 3 would be 5. Okay, what I just said there, this thing times square root of 3 is 5. That means that the thing in here, gosh, can I do that very well, is going to be 5 divided by the square root of 3, which is the same as 5 times the square root of 3 over 3. Okay, that is the length of this little piece right here. And then the radius is going to be double that. It's going to be 10 times the square root of 3 over 3. You know what? I didn't even really talk about a plan. Why don't I talk about a plan first? The plan here is find the shaded area. I'm going to do area of the sector. Sector, which is just degrees over 360, which I know already. It's 120. Times pi r squared. So I had everything I needed in that formula except for this radius. And okay, well I just found it. That's why I was going to tell you about the plan. The radius here is that, and that's how you find it. Okay, so anyway, starting with a plan, that tells you, okay, radius is the thing I want to target. And the only way to get radius is to start with this 5 and do the 30, 60, 90 business. So I got to figure out how to square that nasty radius number. Well, that's 10/3 times the square root of 3. That's 10 square root of 3 over 3 times 10 square root of 3 over 3. You can think of it that way. Which thirds times thirds are going to be ninths. 10 times 10 is, whoops, did I really say half for that? Okay, that was silly. 10 times 10 is 100. Square root of 3 times square root of 3 is 3. And I have a pi here, and I have a 1/3 here. Well, the 1/3 and the 3 are going to cancel each other out. What I have here, what I'm left here with is 100 pi over 9. There you go. Alright, on the other form, it was pretty much the same, except these things would be 4. The degree of the arc is kind of nasty, so this is 35 and 35. Again, what I'm looking for here, the area I'm looking for, area of the sector, is all I've got to do. It's degrees out of 360 times pi r squared, and I don't have r. So r is my wish list right now. And I have a 35-degree angle here and a 4 in a right triangle. I know how to find this thing. Should I call it h because it's like the height of this triangle? Actually, you know what? I don't care about h. I care about r. I can find r without finding anything else, so let's just do that. R is the hypotenuse. Opposite over hypotenuse would be the sine of 35. And that means people are having trouble solving for r when it's trig stuff like this. Remember, you can switch out the r and the sine 35. So this is 4 over sine. It's like I'm dividing both sides by sine 35, and I'm multiplying both sides by r at the same time, and that's how it gets 3 by itself there. All right, so 4 divided by the sine. I can make this so you can see it better. 4 divided by the sine 35. I sure hope I'm in radians. What? Not answer. 4 divided by sine 35 is 6.97. 4 is approximately my radius. I'm just going to leave that in my calculator, though, because I don't need to do anything with it. I can just now put it into here. In fact, I'm just going to go straight to doing exactly that. So I take that, square it, times pi, times 70, and divided by 360. I just kind of went backwards through that equation, and there you go, 29.71. I said hundreds, right? 29.71 is the best way to do that. All right, well, see how this came out 9 on the second form. So one of the forms goes 1 through 8. The other one's going to go 9 through 16, but I'm going through them in order. So this is 2 on that form that was matching my number 1, etc. All right, here's the one where I give you, you can't really see it, but I give you length of, move that down a bit, length of the arc and measure of the arc. Okay, great. Well, I think the only way I'm going to be able to do this is if I do that and I make it the same thing. You notice we do this a lot. I'm going to find that shape minus that shape to give me that shape. We do that a lot. This thing is degrees out of 360, which I have, right? This is degrees out of 360 times pi. Do I have r yet? I should write what I have here. I have this length is 25, and the fact that this length is 25 and it's 56 degrees. So I have these. I mean, there's no reason why I can't put those in right away. It's 28 and 28. And I have that length, which it doesn't really help me. It's nothing directly that I can use. I'm going to use it. I'm going to use it to figure out these lengths and the size of things, but I'm not there yet. So I need to know r squared. This is a half times base times height. And by that I mean this as the height and this whole thing as the base, which you can't really see there, but that's what I need, and that's going to be what I want. Well, I don't have the base or the height or the radius yet, but this 25 is going to help me get it. 25 is arc length. So arc length I know is degrees out of 360. The degree associated with arc is still 56 times 2 pi r. Notice this will help tell me what the radius is. If you think about that, the 25 it's 25 as a piece of the circumference. This is not the whole circumference. This is 56 360th of the circumference. It's this much circumference. And I know from that, I know since that's 25, I can figure out what the whole circumference is supposed to be. And if I know what the whole circumference is supposed to be, I can get radius, and that would be nice. Notice at the beginning of this problem, I have a hundredths direction here, so there's no reason to keep my pi alive. As I go through here, I can go ahead and hit the pi button and destroy it and turn it into decimal smithereens, and I'll have this rounded answer, and that's okay. I'm going to keep it. I'm going to keep as many of those decimals as I can till the end, but it's okay to go ahead and do this. Some people are having problems doing this. I think the first thing I would do would be divide by 2 pi, which is not bad. And then I would take both sides times the reciprocal here, take the 25. This is a lot to write. I really wouldn't even write this, although I should show my work like a good math student. 360 over 56, and that will be r. Okay, so let's do that. If I do this a little bit, I can actually see that. 25, I said the first thing I was going to do is divide that by 2 pi. Parentheses to be safe. Okay, times 360 and divided by 56. So that gives me about 25.57, which is not a whole lot different than the arc. Yeah, great. Well, that's actually not. That's not that unreasonable if you think about it, actually. 25.578. 25.578, okay. I can take it, this is going to be part 1 of a long series of videos. Okay, that was the radius, which is up here. Alright, and I know this angle. I got one side in a right triangle, so I can find the other sides. It's just SOHCAHTOA now. Let's do h next. H over that hypotenuse. You know what? That's going to be my way. Let's move that a bit. Let's put it down here. H over the hypotenuse. That would be adjacent to the 28, so that's cosine. So I can find h by taking my radius times cosine, which is about, there it is, times, see, I can keep it, that decimal in there, it's really nice, times cosine 28. This is a very exact answer so far. 22.584. I needed that because I needed that for the the triangle, and I need to find b here. So that's b's gonna be very similar. B over hypotenuse over that radius is going to equal the sine of 28. So b is about 25 point blah 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 times sine 28, which is approximately, now actually this isn't b. If I call this b and this, well, geez, what should I do? B was supposed to be the whole thing. Let's call this, because I want b to be that, so that's fine. Let's call this x for now. That's really just going to be half of it, so you got to be careful. Okay, so this is x, actually. Let's go back to here. X is 25 point. As long as I can see all that, I'll go ahead and do it. Times the sine of 28. And that gives me just about 12.01. On both sides. Come on, pen, follow me. 12.01. Now I can put all that stuff in here. 56 3/60ths. Should I pause and just write this out or make you watch this whole video? Like, is that helpful? I don't know. 578 squared minus a half. Now here, when I get to b, I gotta be careful. It is the whole thing. It's the 24.02 times h, which I found out a while ago, 22.58. Doing all of those calculations, I get... Yeah, you really didn't need to see me do that on the calculator. Yeah. I get about that much for the sector, that much for the triangle, so the final answer is something like 48.53. Okay. That same problem on the other form is a nice one. I mean, nice numbers. Again, we're going to do sector minus triangle, and for the triangle, I'm going to know the base and the height. Wow, that's a really bad picture. Equals the sunrise piece. So these are 60s. Oh yeah, that's a really bad picture. You know what? I'm actually going to change the picture. I did this on the board. It was just as bad. I'm going to make it look like it's actually a 60-degree, 120-degree angle down there. So it's going to be more like this. Oh yeah, that's better. Nice one. Okay. It's kind of hard to draw straight lines on this screen. Okay. So now this looks like a 60 and a 30. The length of this thing is 14 pi, so this is 7 pi. Oh, I'm sorry. See, that's the mistake most people made. This length is 7 pi. Right. So 7 pi, not 7 pi. Where am I going with the 7 pi? It's 14 pi. Okay. It's been too long since I did this in class. All right. This is 14 pi. 14 pi is a portion of circumference. What portion is it? Well, it's exactly 1/3 of the circumference. The circumference is 2 pi r. Alright, so divide both sides by pi. Done. This is 1/3 times 2. This is 2/3. 2/3 of r is supposed to be 14. So multiply both sides by 3, divide both sides by 2, that would be 21. R is 21. Nice. This is 21 and 30, 60, 90. See, this is so much better than that calculator one, don't you think? And this is 10.5 square root 3. Great, so the whole segment here is going to be 21 square root 3, which I'm going to want to know for this. All right, this is 1/3 times pi times r squared minus half times base. That's a 3 times height, which is not even approximate equal to 21 squared divided by 3. 21 squared divided by 3 is 147 minus. Now I have 10.5. I have 10.5 squared essentially here, don't I? 10.5 squared times the square root of 3. 10.5 squared because it's 21 times a half, and there's another 110 1/4. Oh, that's so yucky. Let's just do this. Oh, isn't that nice? 441 over 4. And there's a square root of 3 here. Oh, I forgot my pi. There's a pi there. 147 pi minus 441 square root 3 over 4. Isn't that just